So we're going to look at reflecting objects or polygons about a horizontal line or a vertical line other than the x and the y-axis. And I'm going to lay you on to some magic here. And the magic is it's actually like a magical phrase, think Harry Potter. And the magical phrase is hoi vux, hoi vux. So let's take a look and see what it looks like. Let's spell it out. H-O-Y-V-U-X. And one of the things that will help you remember this method is hoi vux, because any other method sucks. Anyways, just think about that for a bit. So let's go ahead and take a look and see why hoi vux is so helpful. I want to point out that the H stands for horizontal. So that's like a horizontal line. And the y part means that I'm going to have an equation where y equals something. The O part is really a zero, and I don't know how much we'll be using that in geometry, but when you get to algebra class, this will be the slope, and it means that we have that a horizontal line has a zero slope. Just in case you have a hard time remembering that, this will be one way to do it. Now, the V, of course, is going to be for vertical. And this will be for a vertical line. You will always have an equation where x equals something. And again, the U, we won't use it so much, but it simply means that it will have a line that has an undefined slope. And I'm not going to go into a great deal of detail on what the difference is between undefined and zero slope, but I just want you to know that if you remember this phrase, hoi vux, you get several things for the price of one. You get your equation. Vertical lines have x equal, horizontal lines have y equal, and you'll know whether you have a zero slope or an undefined slope. Okay, now let's go ahead and try to use this in practice. So we are going to reflect a triangle in the line x equals -2. Now, just to refresh our memories, let's take a look and see how we can figure out what this means. X equals -2. I'm going to go back to the thing we just drew. It says that if x equals, we're going to have a vertical line. Vertical lines, hopefully you recall, go up and down, and horizontal lines go from side to side. So in this case, we're going to have a vertical line. It's going to go up and down, and it's going to be at x equals -2. So let's try it. Okay, so let's have some fun with this. Well, I'm going to go ahead and draw the line first. We can either use the graphing calculator and just punch in. Oh, it looks like I started something here. Let's delete that. Let's go ahead and punch in x equals -2. And then it just draws the line. Another way we could have done it is we could have grabbed a couple of points and just picked points that have x coordinates of 2. And who cares what the y coordinates are? We just need 2 points where the x coordinate is 2. So we could have just, picked a point like this one and a point like this one, and then just use the line tool to connect them. But for now, I'm okay with just using the graphing calculator. So here's the line x equals -2. It's this line right there. And you'll notice it's vertical, just like we expected it to be because of hoi vux. Okay, now let's go ahead and take a triangle. Now, so far in the reflections I've shown you, we've reflected an object that's on one side of the line to the other side. But let's do something kind of weird and different. And you know what? Ooh, just for the heck of it, maybe we'll do a quadrilateral. I'm feeling a little naughty right now, so let's try it. So I'm going to go ahead and put down a point, and then I'm going to put down another point, but I'm crossing the line. And then I'm going to go ahead and put down yet another point. Let's make it fun. And then I'm going to go ahead and put down a point over here, something like that. And then I'm going to finish this quadrilateral. So this one's going to be kind of interesting. And again, it might be fun for you to try something like that, approximately graph this, and then sketch the reflection about the line y equals x equal the line x equals 2, x equals -2. If you can pause the video and try it, that'd be great. Otherwise, we're about to go for it right now. So let's see here. I'm going to go ahead and we're going to do reflect about a line. So when I do that, I will select the object and then the line. So man, I really would like you to pause this video and try it on your own first. Oh, it's so exciting. Anyways, here I go. Hopefully you paused it. Here we go. I click and then I click the line. Isn't that fun? I love this. Okay, so I'm going to go ahead and right mouse click on that guy to make this pretty. Let's make it a different color so it really shows up as something different. Oh, that is so neat, isn't it? Now, I think it's kind of a coincidence that this point just happened to be on that line between A prime and D prime, and C prime is on the line between A and D. I don't think that happens every single time, so it might be worthwhile to try a few of these on your own. And again, I would love it if you could try this sort of thing with graph paper and just recognize the fact that in order to reflect, we simply take point A, count the number of squares to the line, make sure that we're exactly perpendicular to the line, and then count from that point on the line that number of squares to get A prime. And then we do the same thing with B to B prime and C to C prime and D to D prime. All you do is count the number of squares. Now again, in this case, I have squares that are, I'm not right on the corner. This would be a bad problem to give you as a test question unless I said just do approximately this. Anyways, so now we've reflected an object about the line x equals -2. Let's go ahead and do a reflection about the line y equals 3. This time, instead of going into the graphing calculator and typing y equals 3, we're going to go ahead and I'm just going to pick points that are at y equals 3. So I'm going to go ahead and pick this point right here, I think. That should be close. Let me go ahead and do the point tool and pick this point, and I can double click just to see, yep, that's at -1, 3, perfect. And then we'll go to the point tool again and go over here, and again just to make sure that that's correct, yeah, 2, 3, great. Okay, so now I can go ahead and make a line that goes through those 2 points. Oh, this is not going to be as cool as I thought. We're going to do y equals 2 instead to make it more fun. So yeah, okay. So let's go ahead and let's do that, y equals 2. So we'll grab our points and we'll go there, and we'll do another point and we'll go there, and then we'll go to this line. We want to do we want to make a line, so here we go, line. We'll go through G and H, and then we'll reflect. So we go ahead and we reflect about a line, and we'll pick our object, our quadrilateral, and we'll pick the line that we're reflecting about, and there she is. Pretty, yes. And again, if we wanted to clean this up, and make it really nice, we can get rid of these extra points we don't need. I'm just hitting the delete key after I select them. I could have gone and done the delete icon, but I did not. Let's go ahead and make this guy a nice pretty red color. And so now we can see the reflection. And again, if we had to do this on paper, on a test, we would just count the number of squares that A is away from this line perpendicular, and then count that number of squares to get to A prime. And then do the same from D to the line, and then get to D prime, B to the line, get to B prime, and C to the line, and then get to C prime. So there you have it. We used the magic of Hoy Vux to figure out whether our line was going to be horizontal or vertical. We looked at x equals and y equals, and we also did things the old-fashioned way. Just picked points that had the coordinates of y equals 2, and we could have picked points that had coordinates of x equals -2. All right, that's a lot of stuff in one video. I'd love it if you could play around with this and try it on your own.